All right, this is number 10, cone for related rates. So we'll go through this again. And this is an interesting problem. I have water that runs into this conical tank at a rate of 9 cubic feet per minute. So you've got water going into the tank. The only thing that's weird about this problem, I think, is to me the tank looked upside down, but that's how they have it. So it's running in, so this is going to be positive because the volume is going in. So they gave us dV/dt by looking at this 9 cubic feet per minute. And the tank stands point down and has a height of 10 feet, which we have right here. And the base radius is 5 feet, which is right there. How fast is the water level rising when the tank is 6 feet deep? So they're looking for, if you will, dH/dt. How fast is the water rising? So they call this x. This is really the radius is decreasing each time. And this is my height, and that is going to be decreasing each time. So the height is decreasing and the radius is decreasing. And again, we have all these similar triangles going on here, so we have to have a proportion going on before we go through and do this. So we're going to call this dH/dt, so we don't know what's going on. Okay? So first, we're going to do the volume is 1/3 pi r squared h. And again, because this is changing, we want to find dH/dt. We want to have this whole formula in terms of h. So we're going to do proportion is my radius to my height, and my radius is 5 feet and the height is 10. We're going to solve for r, so I have 10r equals 5h. So r is going to be 5 over 10h, or a half of an h. So then I'm going to take this right here and, take this right here, this half h, and I'm going to replace it right into the r spot so that the whole formula is in terms of h. So I have 1/3 pi 1/2 h squared times h. So the volume is going to be 1/3 pi times 1/4 h squared times h. So the volume of this is going to be 1/12 pi h cubed. Now again, this volume is strictly for this cone that we have going here. Alright? Now I'm going to go through and do the derivative. So I have dV is, now I got 3 times 1/12, so that's going to be 1/4 pi h squared dh. Go through and divide through by dt because it's with respect to time. And we know dV/dt is 9 cubic feet per minute equals 1/4 pi. And they told us when the water is, because they have to let you know when you want to know how fast it's rising. I should say going down. It's at 6 feet. So we're going to put 6 feet in here and square it, and we're going to basically solve for dH/dt. Okay, so when I have everything in here, I'm going to say 9. I'm going to divide it by everything right here, and I end up getting dH/dt, and I hope it's negative, and it comes out to be negative. No, excuse me, it should be positive because it's going in. Excuse me, is going to be 0.318, and this is in feet per minute. So it's increasing because the water's going in. Okay, so that is just another practice with a cone. Again, I want to reiterate, we only do this part right here where we do that proportion on a cone or something similar where you have two variables that are changing. You have the radius is changing as the water is going down and the height is changing. So we're going to do a proportion before we do our derivative to find exactly what's happening. So that's it.